All right, strap in, everyone, because today we are taking a deep dive into the world of quantum computers
Oh, yeah.
and some seriously mind-bending stuff.
Bring it deep on this one.
We're talking about the possibility that scientists might have, accidentally
Oh, wow.
stumbled on something that could, totally change how we understand reality itself.
Yeah, it's a fascinating concept.
Right.
It really pushes the boundaries of what we thought was possible.
The article that we're looking at today claims scientists may have triggered something called the God particle plug-in while experimenting with quantum AI.
Right.
It all sounds very sci-fi,
It does.
but the implications could be huge.
Absolutely. To understand what's going on, I think we really need to start with, the basics.
Yeah, let's do it.
The God particle is actually the Higgs boson.
Okay.
It's a fundamental particle that was discovered at CERN,
Right.
in 2012.
Okay, I remember hearing about that.
Yeah.
But how does this particle relate to the God particle plug-in and, reality possibly changing?
So the Higgs boson is responsible for giving mass to all matter.
Whoa.
So think of it like this.
Okay.
Imagine the universe is filled with this kind of invisible energy field.
Okay.
The Higgs field.
I'm picturing it like a cosmic swimming pool.
Exactly. And as particles move through this pool, they interact with the Higgs bosons.
Wait.
And that interaction...
So the Higgs bosons are in the pool.
They're they're like little buoys or something in there.
Okay.
And so the particles, as they're moving through, are bumping into them.
Okay.
And that's what's giving them their mass.
So the more a particle interacts with this field, the heavier it is.
Precisely.
Okay.
Now, the God particle plug-in is this theoretical quantum computing function
Okay.
that's designed to simulate and potentially even manipulate this Higgs field.
So they wanted to sort of poke and prod at the Higgs field and see what happens. Sounds a little risky.
Yeah, a little bit, and that's where the quantum anomaly comes in.
Okay, here we go.
During a recent experiment with advanced quantum AI, something totally unexpected happened.
Yeah.
The system started spitting out data that didn't fit with any known models.
Oh, wow.
It was as if some external force was influencing the calculations.
Wait, so it wasn't just a computer glitch?
No.
They, triple-checked everything?
Yeah, they ruled out all the usual suspects, hardware malfunctions, background radiation, all that stuff.
Wow.
Some physicists think that the quantum system might have actually interacted with an unknown force.
Okay.
Something beyond our current understanding of physics.
Okay, now this is where it gets really interesting.
Yeah.
So we've got scientists messing with the Higgs field
Right.
and potentially unleashing forces we don't understand.
Mm-hmm.
But how does that tie back to the idea of reality being altered?
That's the million-dollar question, isn't it? If quantum computers can interact with the Higgs field, which governs the fundamental properties of matter,
Right.
could they also influence the very fabric of reality itself?
That's a mind-blowing thought.
It is.
But let's back up for a sec.
Yeah.
What makes quantum computers so different from the ones we use every day? Why are they capable of this kind of interaction?
Traditional computers, they work within the limitations of classical physics.
Okay.
But quantum computers, on the other hand, operate at a level where the laws of nature are still being defined.
Interesting.
They exist in a realm of uncertainty and probability.
Okay.
They tap into the strange world of quantum mechanics.
And because of that, they might be able to do things that were previously thought impossible.
Yeah.
Like manipulating the Higgs field.
Exactly. But here's the thing.
Okay.
Even the smallest change to the Higgs field could have ripple effects throughout the universe.
Wow.
We could be talking about shifts in physical constants,
Okay.
energy fluctuations, maybe even phenomena we haven't even dreamt of yet.
Now, before we go any further,
Yeah.
I think we need to address the elephant in the room.
Okay.
This whole thing sounds pretty dangerous.
Yeah.
If we're talking about potentially altering reality, shouldn't we be a little more cautious?
Right.
There are some pretty serious implications here.
Absolutely. You're absolutely right. There are some very real concerns about the potential dangers of pushing quantum systems too far.
So are there people speaking out against this?
Yeah, there are some big names in physics who are speaking out about these risks.
Like who? Give me some names.
You got Brian Cox
Okay, yeah.
and Mikio Kaku.
Yeah, I've heard those names.
They've both voiced some concerns.
What are they saying?
So Brian Cox has warned that certain quantum experiments could generate unpredictable energy fluctuations.
Okay.
And those fluctuations could have, potentially catastrophic consequences.
That's a scary thought.
It is.
What about Michio Kaku? What's he saying?
Kaku has gone even further,
Okay.
suggesting that pushing quantum systems beyond their limits might force the universe to reveal new undiscovered physics.
Oh, wow.
Rules that we haven't even encountered yet.
So we could be literally forcing the universe to rewrite its own rule book.
Yeah, it's like we're forcing it to show its hand.
That's an intense thought.
It is.
Yeah.
And to add another layer of complexity,
Okay.
we need to consider that there's a global race for quantum supremacy happening right now.
You mean like a quantum arms race?
Exactly. The US, China, European countries, they're all investing billions into quantum research.
Wow.
Hoping to unlock its potential before anyone else.
And it's not just about like faster computers.
No.
We're talking about like some serious stuff here.
Yeah, we're talking encryption-breaking algorithms, untraceable communication networks, the ability to model and manipulate complex systems in ways we never thought possible.
Okay, so we've got this potentially reality-altering technology and a global race to control it. Now I'm starting to see why this is such a big deal.
Yeah.
But if governments are aware of these risks,
Yeah.
wouldn't they be trying to keep this whole thing under wraps?
It's certainly a possibility. If a government discovered that quantum computers were interacting with the Higgs field, potentially altering reality, they might see it as a matter of national security.
For sure.
Something too powerful to be shared with the world.
This is starting to feel like something out of a spy thriller.
It is a little bit.
We've gone from like theoretical physics to international intrigue in just a few minutes.
Yeah, it's a complex situation.
It is.
With a lot of moving parts.
For sure.
But that's what makes it so fascinating.
Absolutely.
This quantum anomaly raises so many questions about the nature of reality, the limits of science, and the potential consequences of our pursuit of knowledge.
It definitely raises more questions than it answers.
It does.
But that's what we're here for, right?
Yeah.
To dive deep and explore the unknown.
Absolutely.
Let's keep going.
Let's do it.
Okay, so we've established that this quantum anomaly has the potential to be a really big deal.
Yeah, for sure.
And that there are some like serious concerns about what could happen if this technology falls into the wrong hands.
Right.
But before we like spiral into full-blown sci-fi paranoia, let's try to break this down a bit.
Yeah.
What are the specific implications of this discovery? What does it actually mean for like well, everything?
That's a great question, and it's one that scientists are grappling with right now.
Yeah.
The implications of quantum computers interacting with the Higgs field are so far-reaching and, frankly, a little unsettling.
Yeah.
Remember how we talked about the Higgs field being responsible for giving mass to everything in the universe?
Right, like a cosmic swimming pool that gives everything its weight?
Exactly. Well, if we can manipulate that field, even in a tiny way, it could have like ripple effects throughout the universe. We could be talking about subtle shifts in physical constants, fluctuations in the energy structure of the universe, and maybe even the emergence of phenomena that we've never even imagined.
Okay, now that's where my brain starts to hurt a little.
Yeah, a lot.
Could you give me a real-world example? Like, what would actually change if these constants shifted even slightly?
Okay, so imagine the force of gravity suddenly becoming a tiny bit weaker.
Okay.
It might not seem like a big deal at first.
Right.
But over time, it could have a huge impact on everything.
Wow.
From the orbits of planets to the formation of stars.
Okay.
Or imagine the speed of light changing even fractionally.
Yeah.
That would fundamentally alter our understanding of time and space.
So we're not just talking about computers getting faster here.
No.
We're talking about the potential to rewrite the fundamental laws of physics.
Yeah, that's exactly what makes this discovery so profound
Right.
and potentially dangerous. We're venturing into uncharted territory here.
Yeah.
And there's always a risk of unintended consequences.
Of course.
Imagine a world where the very laws of physics are being rewritten by computers. What would that mean for your everyday life?
I don't even want to think about it.
Right. There's a lot.
But I guess that's the point, right? We have to start thinking about these things now before it's too late.
Absolutely. We need to proceed with caution, but we also can't let fear paralyze us.
Right.
This discovery has the potential to unlock some of the universe's deepest secrets.
Yeah, like what?
We might be able to finally understand dark matter and dark energy.
Oh.
Or even uncover the true nature of space and time.
So it's like a double-edged sword.
Yeah.
We have this incredible potential to make groundbreaking discoveries, But we also have to be mindful of the risks.
Exactly. And that's where the conversation about ethics and responsibility comes in.
Okay.
We need to be having open and honest discussions about how to develop and use this technology safely and ethically.
Yeah.
We need to establish safeguards, regulations, and international collaborations.
Wow, so this is like a global effort.
It has to be, to ensure that quantum computing is used for good, not for harm.
I completely agree. It's a conversation that needs to happen not just within the scientific community,
Right.
but like within society as a whole. Exactly.
We all need to be aware of the potential of this technology, both the good and the bad.
Yeah, for sure.
But let's get back to the quantum anomaly for a moment.
Okay.
Do we have any idea what actually happened in that experiment? Was it a genuine interaction with the Higgs field, or could there be another explanation?
That's the million-dollar question that scientists are working tirelessly to answer.
Yeah.
There's a lot of speculation.
Of course.
And researchers are exploring a wide range of possibilities.
Okay.
It could be a genuine interaction with the Higgs field, as some physicists believe.
Okay.
Or it could be something entirely new.
Okay.
A phenomenon we haven't even considered yet.
So we're basically at the edge of the map here, looking out into uncharted territory.
That's a great way to put it. We're on the cusp of a new era of scientific discovery.
Right.
But we're also entering a realm of uncertainty and potential risk.
Yeah, for sure. And that brings us back to the question of government secrecy.
Right.
If this discovery is as groundbreaking as it seems...
Yeah. Is it possible that governments around the world are already aware of it and are keeping it under wraps?
It's definitely possible.
Yeah, it's been on my mind since we started talking about the global race for quantum supremacy.
Right.
If governments see this technology as a matter of national security, it's not hard to imagine them keeping it secret.
Yeah.
But how could they possibly keep something like this quiet?
Right.
Wouldn't there be leaks, whistleblowers, or something?
It's definitely possible, but think about the level of classification that would surround a discovery of this magnitude.
Okay, yeah.
We're talking about something that could fundamentally alter the balance of power in the world.
Right.
Governments have ways of keeping secrets.
Yeah.
Especially when it comes to matters of national security.
True.
Look at the Manhattan Project, for example.
Right.
The development of the atomic bomb was kept secret for years.
Yeah.
Despite involving thousands of people.
That's true. And I guess in the age of disinformation and deepfakes, it's becoming harder and harder to discern what's real and what's not.
Exactly. We're living in a world where information is constantly being manipulated and controlled.
Right.
So even if there were leaks or whistleblowers, it's possible that their claims would be dismissed as conspiracy theories or fake news.
It's a sobering thought.
Yeah.
So where does that leave us? We've got this potentially reality-altering technology.
Right.
A global race to control it.
Yeah.
And the possibility that governments are already keeping it secret, it's a lot to process.
It is. It underscores the importance of critical thinking, media literacy, and healthy skepticism.
Yeah.
We can't just blindly accept everything we're told.
Right.
Especially when it comes to something as profound as this.
Of course.
We need to question, investigate, and demand transparency.
I agree. But on a more personal level, what does all of this mean for the average person? How should we be thinking about this quantum anomaly and its potential impact on our lives?
Yeah.
Should we be worried, excited, confused?
I think it's natural to feel all of those things.
Yeah.
This is a discovery that challenges our fundamental understanding of the world.
Yeah.
It's something that could have profound implications for our future, both individually and collectively.
Right.
But I also think it's important to remember that the future is not predetermined.
Okay.
It's shaped by the choices we make, the actions we take, and the conversations we have.
That's a good point.
Yeah.
We're not just passive observers in this. We have agency, and we can choose how we respond to this new reality.
Exactly. We can choose to be informed, engaged, and proactive. We can demand transparency and accountability from our leaders.
Yeah.
We can support scientific research and ethical development of this technology. And most importantly, we can choose to approach this new frontier with a sense of wonder and curiosity.
I love that instead of being paralyzed by fear, we can choose to embrace the unknown and see where it leads us.
Yeah.
After all, exploration and discovery are what make us human.
Precisely. And who knows what incredible breakthroughs await us on the other side of this quantum leap.
Okay, I'm feeling a little more optimistic now.
Yeah.
But I think we need to take a step back and let all of this sink in for a moment. This has been a lot to process, and I'm sure our listeners feel in the same way. Okay, so we've covered like a lot of ground in this deep dive.
Yeah, we have.
From the mind-bending quantum anomaly to the global race for quantum supremacy.
Right.
And the potential for governments to like keep these discoveries under wraps.
Mm-hmm.
So let's maybe shift gears a bit.
Okay.
And talk about what this all means for us,
right.
the non-physicists, the everyday people, just trying to navigate this increasingly complex world.
Yeah.
What's the takeaway here? What should we be doing with this information?
That's a great question, and it's one that I think everyone should be asking themselves right now. We're at a pivotal moment in history, a point where the lines between science fiction and reality are blurring.
Right.
Quantum computing has the potential to revolutionize everything.
Yeah.
From medicine and energy production to communication and artificial intelligence.
We've talked about the possibility of like curing diseases, developing revolutionary new materials, and solving the energy crisis. Those are all like incredibly exciting possibilities.
They are, but we also have to acknowledge the potential downsides.
Right.
The unintended consequences that could arise if this technology is misused or falls into the wrong hands. We're talking about the ability to manipulate the fundamental forces of the universe.
Right.
And that kind of power could be used for both good and evil.
Right. We talked about the potential for a quantum arms race. For governments or corporations to use this technology for their own gain, potentially at the expense of others. It's a bit unsettling to think about.
It is, but I think the key takeaway here is that we as citizens have a responsibility to be informed and engaged in this conversation.
Okay.
We can't just sit back and let the experts, the governments or the corporations decide the future of this technology.
Right.
We need to be asking questions, demanding transparency, and holding our leaders accountable.
So it's not just about understanding the science.
Right.
It's about understanding the ethical and societal implications of this technology.
Exactly.
And making sure it's used for the benefit of all humankind.
Yes.
Not just a select few.
Exactly. And that starts with education.
Right.
We need to be talking about these issues, not just in scientific circles,
right,
but in our homes, schools, and communities.
Okay.
We need to be having open and honest discussions about the potential benefits and risks of quantum computing and figuring out how we as a society want to navigate this uncharted territory.
So what can the average person actually do?
Yeah.
Besides, starting a book club about quantum physics.
Well, that's not a bad idea.
Right.
But there are other things you can do as well. Stay informed about developments in quantum computing.
Okay.
Read articles. Listen to podcasts like this one, and talk to people who are knowledgeable about the subject.
Yeah.
Support organizations that are working to promote ethical and responsible development of quantum technology.
Okay.
And most importantly, make your voice heard.
How?
Contact your elected officials.
Okay.
Write letters to the editor. And engage in discussions online and in your community.
It sounds like the message here is don't be afraid to dive in.
Yeah.
Ask questions. Learn as much as you can and participate in the conversation.
Exactly, because the future of quantum computing and ultimately the future of reality as we know it is being shaped right now.
Yeah.
And we all have a role to play in shaping that future.
Well said. This has been an incredible deep dive.
It has.
And I think we've all learned a lot.
I hope so.
But before we wrap up,
I
want to pose one final question to our listener.
Okay, him.
What do you think about all of this? Are you excited about the potential of quantum computing?
Yeah.
Or are you concerned about the risks? Do you think we're on the verge of a technological utopia or a dystopian nightmare?
Right.
We want to hear your thoughts.
Yeah, definitely.
So please share them with us on social media or through our website.
This isn't just a scientific issue, it's a human issue.
Right.
And the more we talk about it, the better equipped we'll be to navigate the complexities and make informed choices about the future we want to create.
Absolutely. Thanks for joining us on this deep dive into the world of quantum computers and reality. Until next time, keep exploring, keep questioning, and keep diving deep.